What's up, guys? Welcome back to another video. And in today's video we have a cool imaginary unit expression we're going to be solving in today's video. Now this looks pretty cool. This has negative exponents as well, and fractions and conjugates. So we're going to try to see how to solve this expression, and this involves the knowledge that we already use, like complex numbers, their algebra, how to add, subtract, and multiply, divide them, operations, conjugates, and all this, and the powers of I, the integral powers of I, involving integer powers, exponents. Okay? So now let's examine this first. Now this problem is truly dedicated to the imaginary unit. Thank you, the imaginary unit. And yes, we already established that I is a complex number, so this is technically a complex expression also. So let's get right into it. Guys, so we can examine from this problem that we have, first we have I to the negative 847. Okay? This is the first power, and then we have plus I to the 572. Yeah, sorry. Oh, distracted. Yeah, guys, sorry for that. Comes from my parents. But back to the problem. We can see that we have the first number, I to the negative 847. Now this is negative power, and this is odd, because 847 is an odd number. Okay, and so the answer will be imaginary. It will be either I or negative I, and we're going to find how to solve that later in the video. And then we have plus I to the 572 plus I to the negative 111, 1 into 11. Now there's something interesting you can see here. Yeah, cool. In this, there's a bar above this. Now why? Now this bar basically means the conjugate. And as you know, if z is a plus bi, then the conjugate of z will be a minus bi if a, b are real numbers and I is the imaginary unit. We know this. But the thing is, this is two imaginary numbers, so we can't say this 72 plus I to the negative 111, the conjugate of this, and this bar right here, this means the conjugate. So when you put it above this is a bar to show the conjugate. We can't say this is equal to I to the 572 minus I to the negative 111. Is this correct? The answer is no. This is wrong. Absolutely wrong. Like literally wrong. Don't ever make this mistake if you do, because look, the thing is, look at the definition. A, B are real. There's a real part. These are imaginary. And I is square negative 1. But you see I, but this is not in the form A equals BI. So yes, what we have to do is, we first have to simplify this, and then we'll go on from there. Then we can see here, in the denominator, I to the negative 17 minus I to the power 203, okay? And then we're adding this whole expression to this one, which is also a complex fraction, okay? The numerator is I, 1 minus I raised to the power negative 444, and the denominator is I raised to the power 126 plus I raised to the power negative 234. Okay, so yeah, let's get solving to this. And yeah, you might notice one more thing. When you divide two complex numbers, you're gonna have to multiply the numerator and the denominator by the conjugate of the denominator. But we can see that the denominators are not in the form a plus bi or x plus y or whatever. They're not in the form of a complex number. So we first are going to simplify the terms, and we'll go on from there. Yeah. Okay, guys. So now let's start the video. All right. Where is this? Let's see the solution. Look. Now, before getting to the solution, we need to talk. Now, if you remember the powers of I, you might notice, the powers of I, like I to 0, is 1, I to the 1 is equal to I, and I squared is negative 1, I cubed is negative I. You can see that there's a repetition. And if you go here, if you continue to get I to the 4th equals 1, because I squared into I squared will be 1, negative 1 into negative 1 is 1. Okay? And similarly, I to the 5th power. Now, assuming this pattern, now, and yes, we have talked about, we did talk about like the integral powers of I in the previous video, I think, you know, a long back ago. But I'm just reinforcing the concept. Okay? So yeah, if the powers repeat every 4 patterns, as we can see here, so this is the pattern. Now, if it's repeating, then what would this be? This is correspond to this, and this is corresponding to this. So this will be an I. We can check it out. We can just do, you know, we can just do C, the pairs right here, right? Now similarly, I to the 6th power, what would this be? Well, you can write this as I squared cubed, because 2 to 3 is 6. And this will be negative 1 cubed, which is just negative 1. So this expression, I to the 6th power, would just be negative 1. So can you see? So, and yeah, you might guessed it. I to the 7 is literally going to be negative I. So the pattern repeat, the powers of I repeat every 4 powers. That's what's happening here. You can check it out. It's pretty cool. Like we can write this as I squared into I cubed, which would be negative 1 into negative I. The negatives cancel out. Okay? And we just get I. Because negative 1 to negative 1 is 1. And then 1 into I is I. So it's a pretty cool thing. Okay? Now, so that's how I do all these. So as before, same with I to the 7th power. We could do something like, you know, like we could do something like I to the 4th into I cubed. We're just breaking it down into 2 powers of I. So this would be 1 into negative I, which is just negative I. Perfect. So this way we can find any power of I by now this is another trick to do this. As explained, we have to divide the power by 4, which I already explained in some previous video. But don't worry, we're going to reinforce that concept in this video again with this problem. Okay? So now, yeah, this is negative power. Now, let's start the solution here, okay? I don't want to take too much of your time. Okay? So, solution. Now, when we do the solution here, we first want to simplify the numerator. Simplify the numerator and the denominator. So, we have here, look, first we need to find this. I to the negative 841 equals what? How do you find this? Well, don't worry. We're going to find this. Basically, now, if you're dealing with negative integers, negative powers, there's a rule. You can just write it like this. 1 upon I to the 847. Okay? And at the end, if you get an imaginary number, you can just you can just modify the numerator and the denominator by the conjugate of the denominator to sort of like make it real. You know? Just the denominator real. You know, that's how you divide it. Okay? So now, because there's a rule that you know, a to negative b equals 1 upon a to the b. I'm sure you heard that, right? That's what we're using here. Now we can see, so how do we evaluate I to the 847? A simple trick, can divide. Actually, there's a more simple trick here. You know what? We can just reduce it to this. Look, now what I'm saying is, actually, we can divide. Let's see if this works. We're going to divide 47 by 4. So because the pattern beside 4 numbers, so just divide this 4, 18, 27, 36. 2. Okay. So 44. 11. Okay. Now, yeah, and the remainder is 3. The remainder is 3. And since we can't do any more divisions, because 3 is less than 4, so we're going to stop here. We see that this is a remainder. So, we're going to go back here. We're going to come back here and put this here. Now, yeah, I know it's a pretty cool trick. I just found this out, and it's really cool. You just have to take up this part right here. You just have to divide that by 4, and you get the result. It works. Now we're gonna verify this. This is I cubed, and we can just find I cubed manually. Negative I. Now before moving on, let's verify this. Okay? Just gonna do a quick verification on this. So let's see if I to the 47 is equal to this. Okay? Let's divide the power by 4. Let's see what it simplifies to. So, okay, wait. Okay, I'm gonna divide this. Okay, so let's start off small. Oh look, there's something cool you can see. If we subtract 800, for example, we get 47. Mind blowing. Look, and we don't have to worry about this. You know, like the 200, but it doesn't matter. Look, we get 47, and when we were dividing by 47 before, we're just gonna get the same remainder. Just subtract 44, you get 3. It works, and the numbers here don't matter because we don't need this. We don't need to know the multiplication of this. We just need to know the remainder, and it works. You can test out by any number. Just you have to see the final 2 digits. It works. It's very cool. I trust. That's why. So, yeah. Now that that's verified, let's go back. And yeah, that's why math is cool. So, yeah. The answer is negative I. So, 1 upon negative I. Perfect. Okay, now we can just multiply the conjugate. So, let's see. What number are we multiplying? So, and this, you're going to multiply. Oh, first write this as 0 plus minus 1i. So in this case, a is 0, b is negative 1. So this conjugate, the conjugate of this will be 0 minus 1i, which is 0 plus 1i, which is simply I. So we're just going to multiply the numerator and the denominator by I. Okay? Let's multiply by I. And this will simplify to I. Now, negative I to I. Do the math. This is equal to, we can also write this as I cubed to I. So this will be I to the 4th power, just 1. Sweet. We get 1. And that's the cool thing about math. Now when we simplify that, we get 1. And turns out, this whole expression turns out to be I. Nice. So now we can erase this whole thing, and we can write this as I. So that's pretty cool. And we can see that it doesn't matter if the exponent is negative. If it's odd and there's a minus sign, it doesn't matter. We're still gonna get an imaginary number. But the difference was when we found I to the 847, it was negative I actually. Remember? Yeah. So that's the thing. So actually, the thing is, when we have an imaginary number raised to some power, if it's odd or even, if it's positive, and if it's like the same power negative, the results will be imaginary conjugates. See, look. These are imaginary conjugates. It's really cool. You can try this out, you know, with any numbers, any pair of numbers, any power of I, raise it to, you know. But there's an exception for some even numbers. Like I to the negative 4 is also equal to 1, since as I to the 4 is always equal to 1, because 1 upon 1 is 1. So, but yeah. So now we have our answer. Not the full answer, okay? This is equal to I, okay? So, but now we need to find this. I to the 572 plus I to the negative 111. Now, before finding the conjugate of this, I want to first simplify what's in here. Yeah, we should do that. I think we should simplify what's in here first. This part. My god, bro. It's not working. Yeah. So, before finding the conjugate, let's simplify this. So, let's quickly use the powers of I. Divide this by 4. And using our trick, we can get rid of this. So, we can just break this down as I to the 72 plus I to the, I to the, look, plus 1 upon I to the 11th power, because we can just take these two powers we have, okay? Because at this point in the last when we are evaluating when we were evaluating this expression, we got to know that we can just take the last two digits of the number and the power reverse. So now, let's quickly simplify this. Now, what's I to the power 72? We can divide by 4. Okay. Let's start it small here. 62, 1, 12. Oh. Turns out the remainder is actually 0. And we know that when the remainder is 0, we can write the power as the remainder. So you got I to the 0th power, which is 1. Nice. Okay. So now this will be equal to 1 plus this. Okay. So I to the power 11. Okay. Divide by 4. 8. 3. The remainder is 3. So this will be I cubed, which is negative I. Sweet. So 1 upon negative I. Now, we know that in the last example, this is the exact same solution we got from this. 1 upon negative I, remember? Just multiply the conjugate, multiply by I, so it'll be I squared the 1. So this will be I. This will be I. Nice. The things are going down, And now we have a complex number here. 1 plus I. So let's go ahead and plug these two values in this expression. Okay? That's what the question here. Okay? So now we can write the expression as one more thing. The conjugate of this, we have to flip the sign. So this will be 1 minus I. So इसका conjugate होगा 1 minus I. Okay? We flip the sign. That's what we did here. Okay, good? All good? Yeah. Now, let's sub these values back in the original expression. So, we can rewrite this as, I plus 1 minus I. So, it'll be I plus 1 minus I, okay, upon I to the negative 17 minus I to the 203. And now, before adding this, there's something you should notice here. Look. Okay, let's see if you notice. Let's see if you guys notice this. Now, can you see any simplification going on here? Look. I, negative I. Cancel! Amazing. Look at this. We successfully simplified the expression. 1 and minus I cancel out, and this is just 1. It's 1. Okay, nice. So this is 1. Awesome. Now we're not done yet. We're not done. Okay, so actually, what I'm gonna do is, since I don't have enough space, I'm gonna rewrite this expression as 1. Okay? And I'll write the answer. And you know what? In the end, I will put the question and the answer after the question first and the answer after it at the end of the video, so you know the question. Okay? So you can take a screenshot of this if you want. Okay? Now, to know this, it's time to do the denominator. Okay. So just very quickly, I to the 203, so 1 upon I to the 17th power minus I to the 203. Okay? Now, see, 4 down by 17 minus 16 will be 1. So this will be I. That'll be I. This is equal to, this expression just becomes 1 upon I. Now, multiply by the conjugate. And a fun fact, the conjugate of an imaginary number is the additive inverse, because I plus minus I is 0. Okay, cool. So this will just become minus I squared is -1, -1 is -1. So 1. This is negative I. Okay, so I'm going to write this whole expression as negative I. Negative I. Okay? So now, we wrote this as negative I. Let's quickly find I to the 203. We can ignore this, the 2. You can ignore this. Oh look, 3. So I to the 203 is just equal to I to the 3. And 03 is just 3. Because we don't need a 0. Because 03 is just 3, so look. The last 2 digits are 3. 03. Because we explained in the further videos, in the previous examples, I mean, we can just take the last 2 digits. Alright, so now this is just I cubed. And I cubed is negative I. So we're gonna write this as minus negative I. Make sure of the brackets, okay? Make sure. It's important. So this becomes this. And this cancel. So we get negative I. Ooh, plus I. Another cancellation. Because this is just, because negative I plus I gives 0. Awesome. Awesome, bro. Awesome. No, not the answer. This is the answer to this expression, not the whole expression. So now, oh wait, what the hell? Wait, this expression is undefined. Dude, what? Oh my god. 1 upon 0. Yes. Huh. You guys have been tricked for some reason. Oh my god. Damn. What? What? Bro, no way. How is it undefined? Oh no. Oh my god. Oh my fucking god, bro. Oh my god. Oh my god. Okay, no. Oh yes, you know what this means? Actually, this means that this part is cancelled. This part is removed. So yeah. Holy moly. This is undefined. 1 upon 0 is undefined. So we have just removed this portion from our answer. Wow. Can you believe that? We just removed that portion. Like literally. And now we just have this expression. See how math deceives you? Man. Bro, I didn't even know. I swear, I didn't even know that was undefined, bro. Oh my god. Okay, well now we just have to add on this. 1 minus I to negative 444 upon I. Yeah, I'm so shocked. Like how does it even get? Yeah, see, you gotta watch out for that. You gotta watch out, guys. Ooh, an undefined expression. Be careful with that, guys. Now, I hope this is not undefined as well, because the fun will be taken away. And if it wasn't, we'll see. So now let's quickly find the values of I. Okay, let's see here. So let's find these three. We're gonna find I to the minus 444. Then we're gonna find I to the 126. And then we're gonna find I to negative 234. Let's find them. Okay, I to the 44. You can ignore this 4, just take the last 2 digits. So I to the 44. The reason we ignore that is actually because when we divide, we get this part as some remainder, not the actual remainder. But when we divide, we get like a leftover, like 44. You know, that's how we get. Like when you divided, we got the previous examples. So okay. So now, actually, when you divide 44 by 4, this is 11. No remainder. So this is actually I to 0 power, which is 1 upon 1. This is 1. Amazing. Now, let's see here. Wait. Do you see this expression? This is 1 minus 1 upon this. 126 plus I plus negative 234. Wait! This is 0. This means this whole expression is equal to 0. And so we don't even need to do this, because 0 divided by anything is 0. Oh my god, guys. So, yeah, we just found this. This is equal to, this whole expression that we have is just equal to 0. Answer to the whole expression. My god. Like, this is insane. Whew. Well, guys, the answer to this problem is 0. And it's really cool how this is undefined and this is 0. Like, math is cool as hell, bro. Like, I know that. And also, I'm not sure if I add a square to this. No, because, yeah, I was supposed to, but the trick is, that wasn't even needed because it's undefined. So squaring an undefined number makes no sense. And remember, when you solve these kind of expressions, do not square the numerator to the denominator. It'll make it like verse. You gotta simplify the inside first and let's see what happens. Man, math is cool, bro. Anyways, I hope you enjoyed this question on the imaginary unit. Okay, it's a cool expression. But yeah, we'll see y'all in the next video.